Okay. So it is a user defined blueprint or prototype from which. So why are classes user defined? Classes are user defined data types. Okay, class is also a data type, but it is user defined. Okay, because the user, it is up to the user how the user wants to, you know, create the class. Okay, what will be the components in the class, what the objects, actually depends on the objects of that class. Okay, what those objects comprise of. So you know that a object will consist of, different types of data. Yes, heterogeneous types of data. For example, object can have a name which can be of string type, right, or array type, whatever you call it, the character type or string type. Then of course, then roll number will be of integer type, total marks will be of float type or integer type, and so on. So as you know that objects consist of, data, and that those data can be of different types, right? They can be of heterogeneous types, means different types of data can be inside an object. So when you group all those objects together inside the class, so ultimately what does the class contain? The class contains all the data members and member functions that, belongs to an object, right? So all the data members that belongs to the object, and the member functions that the objects uses to interact with the outer world, right? So as we know that the data members and the member functions can be of variable types, can be of different types, right? So the user will use, the user, it's up to the user what type of, what type of data members the program will contain. Okay, the objects will have, possess, or what will be the return type of the functions and so on. So accordingly the user defines, okay, this data type, that is the class, right? So it is a user-defined blueprint or prototype from which objects are created. It represents the set of properties or methods that are common to all objects of one type. So objects of one type means, if I ask you what is the type of an object, I remember telling this to you repeatedly in the previous semester. When we say type of an object, type means what is the type of an object? Object belongs to what? A class. Yes or no? So the type of an object is always a class. Always remember that. Okay. When we say type of an object, when you say what is the data type of roll number, you will say roll number is of type integer. Yes. When you say what is the data type of name, you will say name is of type string or array of characters, right? If I say, if I ask you what is the data type of percentage, you will say, ma'am, percentage is of type float. Type float means float, percentage contains float type of data. Okay, so objects are of type classes because objects belongs to classes. Okay, so the class will identify what type of object those are. Okay, so if objects are of type, if there's a class student, okay, and there are objects like student 1, student 2, student 3, and I ask you that what is the type of student 1, you will say, ma'am, it's student, because it is the class name. Okay, student 1, student 2, student 3, all these different students belong to the class student. So the type of the student objects is the class name, which is student. Okay, if I say a bike, okay, a truck, a car. Okay, if I ask you that what is the type of bus, car, truck, rickshaw, you will say, ma'am, vehicles, because these are all objects. Bus, truck, these are specific, right? Bus is a specific type of vehicle, right? So bus, truck, car, scooter, motorcycle, any type of vehicle. When I name the object, you will have to define the type, and that type is the class to which the objects belong, which is vehicle class. Okay, so this is what type of an object is. Never forget this. Next, coming to object, it is the basic unit of object-oriented programming, and it represents the real-life entities. Real-life entities share two characteristics, that is state, behavior. Okay, they all have attributes and behavior. Sorry, attributes and behavior mainly. Okay, so an object. So basically, what an object contains. First is state. That means state means the attributes that belongs to the object. Okay, so it is represented by attributes of an object. It also shows properties of an object. So though the name state has been used, but state is nothing but the properties or the attributes that belongs to an object. Okay, the data members. Okay, then behavior, or let me just give it here, data members. Okay, behavior. Behavior are the member functions. Okay. Behavior are the member functions. So all the methods that the object uses. Okay, it shows response of an object with other objects. So how the different objects communicate. So objects either communicate with other objects or objects communicate with the outer world with the help of methods or member functions. Next is identity. So the identity is the name of an object. Okay, so every object has their own name. Yes or no? Every object, like if we are objects, we have our own identity, and the identity mainly comes from our name. Okay, our identity comes mainly from our name, first name, last name. Okay, if you call, if you take the entire name, because some people have their first names same, so you can distinguish using the last name or surname, whatever. Okay, so basically identity in case of objects is the name, unique name which is given to an object. It also grants permission to one object to interact with another object. Because names are unique, so one object can uniquely call another object by its name, okay, while they communicate. Okay, so this is a diagrammatic representation of object here. These are the three characteristics, okay, identity, attributes, and behavior. So identity is the object. Okay, this is an object, not a class. Okay, so this is the name of the dog. Okay, so I have a pet. Okay, I don't basically you know call her my dog. Okay, she's like my sister. She's very dear to me. Okay, she's very dear to me, and her name is Belly. So this reminded me of her. So anyway, and she's the cutest. Okay, so the name of my dog, suppose identity is Belly. Okay, that's the name. Okay, then attributes. So in this case, in this example, though it has been given separately, okay, though it has been identity has been given separated by anyway, name or identity is also one type of an attribute. Okay, so although it's given here separately, identity, as I said, identity is nothing but the name of the object. So although the name has been given separately here, but anyway, when you design a student object, of course, name comes inside the object. We add name as an attribute inside the object itself, right? So that also is, that is also correct, and this is also correct. Okay. So if you want to address the name of the object separately as a different feature or a different characteristic, then you can call it identity, and you can write the name here. So name of my dog is Berry, and then in attributes you have breed, age, color, right? And in behavior, okay, what breed is it? So it is golden retriever. Then age, she is of 6 months, 6 years. She is 6 years now. This November she'll be 6 years old. Then color is, her color is olive color. Okay, a mixture of white brown. So next, behavior, barking, sleeping, eating. So this comes under behavior. Okay, so in this case, attribute has been distinguished from identity. Okay, they have been considered differently, but anyway, till now we have been using name or identity as attribute only. Yes or no? Inside classes or inside objects, we have been using name of an object as the entity, or sorry, as the attribute only. If you recall the student object has name, roll number, marks, right? So identity is not considered separately. Okay, so both are correct, but anyway, though in this example it has been given separately, but while we'll program, okay, just like in C++, in Java also, we'll consider the name or identity as a part of an attribute list. Okay, so we'll consider it as an attribute. Anyway, so now let's come to classes. So this is the diagrammatic representation of an object. Now, when we consider a class, because there can be multiple objects belonging to the same class, dog. Okay, so this is the class dog, and inside this class dog, okay, these are the various dog objects that belongs to this class. So this is dog one, this is dog two. Okay, so dog one will have its own attributes and behavior. Dog two will have its own attributes and behavior. Dog three and dog four are also another two objects of class dog. Okay, so each of these four objects belongs to the class dog, and each of them will have their own attributes and behavior. Okay, own attributes and behavior means the values for the data members will be different. Okay, and the behaviors will be different. Okay, they'll function in different manner. So that was all. Okay, so okay, now this is one program, like programmatic representation of student. Okay, it's a program. So you know how we represent classes and objects, right? So say this is a student object. So inside student we have these data members here, roll number and name, right? Then because we don't have any declaration, access specifier, so by default what will be the access specifier? By default what will be this data? What will be the access specifier for this? Can anyone tell
Ma'am,
me?
it will be private.
Yes, it will be private. By default.
Ma'am, it will be private.
Yes, but it will be private. Okay. So and public. Okay. So members data member functions have been considered as public. So we have two data member functions here, read and display. So read will help us read the values into this. Okay. Input the values into this data members, and display will help us to output the values that we have input. Okay, that we have read into this data members. And then after this class, we have created two student objects S1, S2. Okay, S1 dot roll, S2, S1 dot read. Okay, so what are we doing here is, okay, now S1 dot roll. So now if I ask you that is it possible S1 dot roll, now you see S1 is an object. S1 is trying to access a data member role, but role is of private type. So can you access the role using S1 or S2? Can anybody tell me? Is this statement
No,
valid?
ma'am.
Anybody else?
No, ma'am.
Can you access role using S1 or S2? Can you, or any object of this class?
No, ma'am.
Huh? Can we access role or name data members of the student class using the objects of student S1, S2? No, because we have already learned about access specifiers and the restrictions that they hold. We know that private members are always private. Okay, so when we declare, that is what data hiding is all about. Okay, that is what data hiding. This is how we hide data from the outer world. Okay, from outside access. So if role and name have been declared as private, or if you can explicitly declare them as private by writing the private label here, or even if you don't give any access specifier, by default it is private. Even in Java also it's by default. Oh, sorry, in Java it's public, I guess. Anyway, I got confused. Anyway, let's come to Java a bit later. In Java, I think by default it was public. I got confused. Anyway, yeah. So, coming to this, so because it's private, we are talking about C++, okay? So because it's private here, so student S1 and S2 cannot directly access role, okay? So that is why this statement will be not valid. It will give you an error, okay? So if you want to access role or name, you can do it in only two ways. One is by calling the read method, and by calling the display method. So by calling this statement is valid, okay? S1.read is valid. So by using S1.read, you can, through this read method, okay, you can read values, you can access this members, private members, and you can read values to it. And through this display, public display method, you can again access this data members to display the values. Okay, so this is the diagrammatic representation. This is the class student. Okay, this is the data section, and this is the functions section. Okay, then these are the two objects S1 and S2. So S1 will have its own copy of values, and S2 will have its own copy of values. That means for S1 the role and name will be different, and for S2 role and name will be different. Is it clear?
Yes, ma'am. Yes, ma'am.
Okay. Next, So you know all these, right? I'll share this document with you. I already have it. It's same. The syntax is same, okay? As we already have learned that Java is completely based on C++. Syntax remains the same, okay? The way we declare classes or objects in C++, here also we do it in the same way, okay? This is the general form. This is the way, okay? You know encapsulation, I've already taught you encapsulation. Okay, now let's look at this example here. We have an example here, okay? So see, this is a box class, okay? Then we have three member functions with height depth, okay? In Java, as I told you, in Java, by default, okay, members are public. Okay, so this is the box class. We have three member functions which are public with height and depth. Okay, then we have another class here. Okay, we'll not just don't I'll, we'll get into the details of this. Okay, of certain we'll get into the details of certain statements like this, no, public static void main. So we haven't used this in C++, so we'll get into details in the next class. Okay, for the time being, just see here. I'm mainly focused on the new operator mainly for this example, so we can ignore certain parts for the time being. Okay, so here in this example, we have two classes, the class box and the class box demo. The class box contains only the data members, okay, and then the class demo contains the main function. Okay, so in C++, if you recall the C++ programs using C++, we saw that, you know, the main function can be written outside a class because C++ is not a purely object-oriented programming. Okay, it is partially object-oriented, partially procedural. So main function can be considered only as a function. Okay, but in Java, everything is considered as an object. So when you want to use an object, you have to have a class. Okay, so that is why everything, if you want to use an object in Java, because as I said, everything in Java, Java considers everything as an object. Okay, that is why if you want to use anything in Java, any object in Java, then you have to use class. Okay, so here this class declares an object of type box. So that is why the main function. Okay, so inside the main function, what did we do? Inside the main function in C++, let me again get back to the previous slide, previous document. In this program, if you see, okay, we would have written this statement inside the main function in main, and then after which we declare the objects of the class, right? In main, so main is nothing but the method. Okay, and inside main we are declaring the objects of class student. Okay, but in Java, even if you use the main function, you have to use it inside a class, because it is that class, okay, it is that class which will contain the main function, and the main function will implement the object of that class. Okay, so because we are implementing objects of the class student, okay, I'm talking about Java, because in Java we will be implementing objects of the student class inside main function. Therefore, we have to make use of a class to do that. Okay, so whenever you want to implement any object in Java, you have to make sure that you have a class. Okay, so though in C++ we did not use any class while declaring the main function or while implementing the objects of this class. Okay, main is simply a method here. Main does not belong to any class. In Java, main has to belong to a class. So main will be a method, just like read and display. Main will also be a method of a particular class that will implement the object of that class. Okay, so in this example here, okay, though class box, we are dealing with box class, so we have to create objects of the class box. Okay, we will have to create objects of the class box, but who will create the objects of the class box? It will be created by the main method. Okay, inside the main method we will be creating the objects of the class box. Okay, and this will be inside the entire main method, will be inside, you know the class box demo. Okay, because we are implementing an object here inside the main method, so therefore we need to have the main method inside a class. Okay, so in this case we are calling this class box demo. Is it clear? Then in the next statement, as you can see here, had it been C++, we would have simply written void main or int main, right? But here we have certain keywords like public, static, void main, followed by string args. So we'll come to this later. Okay, I'll explain it tomorrow. Okay, tomorrow we'll explain, come to this in details. Okay, for the time being, let's focus on one thing, that is the next statement. Okay, box, my box equal to new box. So let's again get back. So had it been a C++ program, तो हम लोग box, ये जो box object है my box, ठीक है? Just look at this statement. Box followed by my box. So what is this box? Box is this box class, right? Followed by another name, which is my box. So my box is the name of the object, right? So this is how we declare objects even in C++. We write the class name followed by the object name, like student S1, right? Box, my box, or box1, however you want to name the object. Okay, so box, my box. So this is the class name followed by the object name, right? But in C++, we end the statement here itself. Yes, here you can see that we have continuity of the statement, right? We have equal sign followed by the new keyword followed by box. And what is this box? What is this? It is the class name. It is the class name followed by parenthesis. So can anyone tell me what is this? What is this box? Class name followed by
Ma'am, it is a
parenthesis.
method.
Huh?
Ma'am, it is a method.
It is a method. Anybody else? See, Java, though you are learning Java, doesn't mean that concepts will change. We have the same concepts in that you used in C++ in Java also. For example, you have polymorphism here, you have inheritance here, you have constructors here. Okay, and it is the same way we use in C++. So what is this box? First you tell me, box, what is this box? Isn't box the class name? Yes or no? Isn't box this class name?
Yes, ma'am.
Yes or no? The rest please respond.
Yes, sir.
Again, I always tell you that although there's one class representative does not mean that he will keep on representing the entire class even for the classes also that I conduct, right? Box is the class here. Yes. So what do we have here? Box, right? So here it is, this is the class name. It is just the class name. But in this case, doesn't it look like a function? Because we have the name followed by parenthesis. So doesn't this look like a function? Yes or no? When we call a
Yes, ma'am.
function, yes, it looks like a function because
Yes, ma'am.
we have the function, we have a name followed by parenthesis. So this is how we call a function. A function call looks like this, right? But the name of the function, what is this name of the function? It is the class name. So what is this actually? The
Ma'am,
class.
constructor.
Yes, it is the constructor. It is the default constructor. Okay. This is the default constructor. In C++, let's again do some comparative study. Here in this statement, we have the class name followed by the object name, right? So here we don't have any other thing. This is not an expression. This is just a statement, right? We don't have equal sign or we don't have any other thing. So here also we are making use of constructor, but we are not naming it. So by default, if you don't have any arguments, okay, because as we know that even if we don't declare the right constructors in our program, it is always a default constructor which gets invoked, but the default constructor is empty. So though we are using the class name followed by the object name, okay, so when this statement will get executed, S1 and S2 if objects will be created, okay, and during that time, the default constructor will be called, okay, but here we don't have to explicitly write like this, okay, like student, we don't have to write the constructor here. If you are using any parameterized constructor or copy constructor, then you have to explicitly mention like this, right? You give some parameters, say 1 comma and then right say name A. In that case, the parameterized constructor will get called. But now, because we are not using any parameters here, we only have the class name followed by the object name. So here in this case, the default constructor will get called. In Java, there's a way of writing the statement. Okay, so in Java, we follow this process. We will have the class name followed by the object name, just in the previous example. Then we have the equal sign followed by a new keyword. So this is a new keyword. Okay, this is a new concept, a new operator or the new keyword, which will help you create a new object for the class. Okay, so this new keyword is actually like a pointer. Okay, it is actually like a pointer to a new block of memory. Okay, it is actually when the new operator will be invoked, a new block of memory, because we are creating an object here, so of course we need a block of memory that will that will be declared as an object. That block of memory will be used by this object that has been created. Okay, my box. Okay, so this new operator will take us to a block of memory. Okay, and that block of memory will represent this object. Okay, and box constructor. So after new operator, it is mandatory that you use the constructor. Okay, so the constructor can be any type of constructor. Here we have a default constructor, which is box followed by parenthesis. Okay, and in the argument, the argument list is empty here, so which means it's a default constructor. Is it clear? So this is how in Java we declare objects. Okay, class name followed by the object name followed by equal sign followed by new operator followed by the constructor. Here we have the default constructor. Okay, so this is what I wanted to show you now. Okay, we'll not get into details of the program. Okay, so now let's come back to the new keyword. So see here, declaring objects. So obtaining objects of a class is a two-step process. First, you must declare a variable of the class type. So variable of a class type means the object. Okay, so if class is the data type, then object is the variable. Clear? Just like you have data types and variable in terms of ordinary, in terms of procedural programs, or in terms of the local variables that you declare, right? Data type and followed by a variable, ordinary variable. So here class name will act as the data type, and object name will act as the variable. Okay, so you have the class name followed by the object name. Okay, now this variable does not define an object. Instead, it is simply a variable that can refer to an object. Okay, so here what is it saying? That in this case, okay, in this case, when this statement will be executed, first each word will be executed one by one from left to right, right? So first box gets executed. So box is the name of the class, then comes my box. So in this case, my box is nothing but my box is just a reference to the object that will be created using the new operator and the box constructor. Okay, understand? I'm repeating again. In this case, my box is not an object. It is a reference to the object. That means my box is only pointing to a block of memory that the new operator will create while constructing the object using the box constructor. So every word in this statement has got its own function. Box is the class name. So we are to create a box variable of type class, of type box. Okay. So whatever object you will create, that object will belong to the class box that you know. Next comes the object name. So had it been C++, then this would have been an object. Okay, this would have been an object. Okay, so a memory block would have been created in the name of this object, and then you could have directly inserted values inside that object using the data members and the memo functions, right? But in case of Java, this is not an object. This is a reference to the object. Reference means this is just a variable which is pointing to a memory location, okay, which is pointing to a memory block, and that block, who is creating that block? That block is being created by the new operator along with the box constructor. So this new operator along with the box constructor will create the memory block, okay, for an object that will belong to this class. And the name, the reference, okay, how are we going to refer to that block? Because we need to have some ways, we need to have some means to refer to that block, to be able to call that block, okay, or to be able to point out to that block. So how are we going to do that? Using the my box name. So this is not an object, but it is a variable which will refer to an object that will be created for the box class using the new operator followed by the box constructor. Am I clear or not?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
See, in Java, everything has got a concept. So it's very important for you all to understand the concepts. Every word has got a meaning. Every word has their own function. They have their own function. Is it clear? So using the new operator, we will create a memory block, and that block will be referenced using the myBox variable. So it's just a variable which is pointing to the newly created block of memory for the object that will belong to the box class. Okay, so my box is just a name of that block that will be created. Yeah, so that is what is given here, that the variable of the class type, that is my box, that is simply a variable that will refer to the object. Okay. Second, you must acquire an actual physical copy of the object and assign it to that variable. That means you actually need, so after you have declared the class name, after you have written the class name, then the class variable, which is the object name, the object reference name, okay. After that, what you are supposed to do is, because the object name that we have given here, that is my box, that is just a reference, that is just a variable, right? But now we have to create an object. So to create an object, you need to create a physical block. To have a physical copy of that object, you need to have a block of memory where you will be inserting values. Okay, you need to have a physical block of memory where you can insert values for that object, and only then you can have the physical copy of that object or actual copy of that object. So who will do that? It will be done by the new operator, as I said. So the new operator will dynamically allocate. So we have already studied this in the Java features, that Java, what makes Java a robust language? Java is robust because of various reasons, and one being that Java does dynamic or automatic memory allocation and deallocation of objects. Yes, so Java makes automatic memory allocation and deallocation, automatic or dynamic. It will dynamically create. Okay, when the dynamically create means when the program is in execution. Okay, बिफोर हैंड क्रिएट नहीं करके रखता है, ठीक है। जब प्रोग्राम कंपाइल होगा तब क्रिएट नहीं होगा, जब प्रोग्राम रन होगा, जब प्रोग्राम रन हो रहा है एग्जीक्यूशन टाइम में जहां पे भी एक खाली ब्लॉक मिला अकॉर्डिंग टू द नीड ऑफ द प्रोग्राम, वहां पे वो डायनेमिकली एलोकेट कर देगा एक ब्लॉक ऑफ मेमोरी ड्यूरिंग रन टाइम। डायनेमिकली मींस ड्यूरिंग रन टाइम, ओके। मेमोरी एलोकेशन इज मेड, so the new operator is used for that purpose. You have also learned new operator in C++, right? While because when we want to dynamically allocate or free up the space, we use the new operator to dynamically create a space, and to remove that space we use a delete operator. So that was what we used in C++, right? But here again we'll use the new operator to create a physical copy of the object, and then we'll refer to that physical copy of that object. Okay, we'll assign that copy to the variable, that is my box. Okay, so this is just a variable. I'm again repeating so that you don't forget, because you have a very good habit of forgetting things just a minute after I speak. So once the physical copy is created